Hello students, very warm welcome to all of you in today's class. In this class, we will discuss about the last topic of electrochemistry chapter. You know that it is batteries and cell. It is completely a theoretical topic and averagely important for your competitive examination as well as your board examination. When we hear the word battery, what come in your mind? Battery is something that is providing you electrical energy or something that is converting the chemical energy stored in itself into the electrical energy. There are various different types of batteries depending upon their uses. In today's lecture, we will discuss all about these. Let's start. Batteries. Batteries are obtained when cells are connected in series. About 2, 3 or 4 or more number of cells are connected in series, then what we obtain is called the battery. Okay? It means we can say that the battery are the collections of cells. Batteries are the collection of cells. Batteries are the arrangement in which more than one galvanic cells are connected in series. Okay, bachcho? Batteries are used to convert the chemical energy stored in itself into electrical energy by using the reaction what we call the redox reaction. Okay. Lot of batteries or the different varieties of batteries are available in the market and in our surrounding. If we have to choose a battery for a particular use, we should have a criteria on which we have to choose a single battery out of so many batteries available in our surrounding. These are the good characteristics of the battery or the uh, good characteristics of a useful battery. Let's listen. Before choosing a particular battery, you should know about some things. Okay, battery should be light. Why it should be light? If it is light, you can transport or carry it any place where you want. Second, the battery should have a long lifespan. It means longer life period time, about 3 days, 4 days, 5 days, and even months. Okay, battery should supply a constant voltage during its use. It means you are using a battery. Initially it is providing high voltage, after few minutes it start providing lower voltage and again providing high voltage, then it's not a good battery. The battery will be good if it provide a regular constant supply for voltage for a longer period of time. Fourth important point about the good rechargeable battery is that it should be rechargeable. That is, it can be easily recharged for a number of times. The last important point for the environmental friendly person is that the battery after using should be easily disposable. Should be easily disposable without causing any environmental pollution. Without causing any environmental pollution. Okay. Now it's time to discuss about the different types of battery, primary battery and the secondary battery. As you are seeing on the screen, there are the two different type of the battery. The first one is the primary battery and the second one is the secondary battery. As the word indicate, the primary is the simplest version of the battery which can be used only once in his lifetime period. That is, use and throw type battery is known as the primary battery, that is could not be recharged. Okay, primary battery is not rechargeable, while the secondary battery is rechargeable. Secondary battery is the advanced version of the primary battery, that is once get discharged can be used or can be recharged further by using it. Okay, we can recharge it for further use. Second important point is that uh, in primary battery reaction could not be reversed. In primary battery reaction could not be reversed. That is, reaction could be carried out only in one direction. If the reaction is forward, then it will always be forward. Okay. If the reaction in the secondary batteries, as you are seeing that the reactions are reversed. For example, in the secondary battery during the charging time, let's assume it is a forward reaction, but when the battery is going to discharge, the reaction will be the backward. It means in the secondary battery reaction can be forward as well as the backward. One important point we all know but could not focus is that in the primary battery, uh, प्रोडक्शन कॉस्ट इज वेरी लो. इट मींस प्राइमरी बैटरी को बनाने के लिए जो प्रोडक्शन कॉस्ट आता है वो काफी कम होता है. आपने भी देखा होगा कि प्राइमरी बैटरीज होती हैं अबाउट 10 रुपीज 12 रुपीज में इजीली अवेलेबल हो जाती हैं, 15 रुपीज में अवेलेबल हो जाती हैं. लेकिन हमारे पास जो सेकेंडरी बैटरीज होती है जस्ट लाइक अवर इन्वर्टर बैटरीज, वो बहुत ही हाई कॉस्ट पे अवेलेबल होती है, 15,000 20,000. इट मींस प्रोडक्शन कॉस्ट ऑफ द सेकेंडरी बैटरीज विल बी हाई. ओके. Next important point, we are comparing both. Supply low voltage. It means primary battery is going to supply the low voltage. The battery present in our watches is supplying a low voltage but for a very long period of time. While on the other hand, secondary batteries supply heavy voltage or high voltage, you can say. Supply high voltage but short period of time, just like our inverter battery. Once it charged, it can supply about 4 to 5 hours backup. And important point we should remember is that primary battery has a long life cycle. Long life cycle means once it is charged, primary battery, once it is fully charged, you can use it for about 3 months, 4 months depending upon the usage. Okay. But the secondary battery, once it fully charged, can be used for about you can say that 3 hours 4 hours only. Okay. Now important point which you should learn or memorize is that primary batteries of two different types, that is dry cell and the second is the mercury cell. They are the two important examples of the primary battery, the mercury cell and the dry cell. Mercury cell and the dry cell. Okay. The secondary batteries are the lead storage battery, or you can say our inverter battery, and the nickel cadmium battery. Hope you come to know the difference between the primary and the secondary battery. Moves onward. Now these are the types of batteries which we will learn in details. Dry cell, it is a primary version of the battery, or you can say the primary battery, also known as pencil cell because it's look like pencil, and also known as the Lagrange cell. Why? Because it is discovered by the G. Lagrange. Now we will discuss about the construction of the dry cell, how this dry cell is constructed. These dry cells look like you can say a container made up of zinc. A container made up of zinc. This container which is made up of zinc acts like anode. Okay. And at the mid of the zinc container, you have a carbon rod or the carbon graphite rod, black color rod, which are not touching to the bottom. Okay. In between the zinc container, which is acting like a anode, and the carbon rod that is acting like cathode, you can say it is already written, it is acting like cathode. The space between the anode and cathode is filled with an electrolyte or the paste of manganese dioxide. As you are seeing here, it is filled the manganese dioxide and the carbon along with some electrolyte like ammonium chloride and zinc chloride. This space is filled with some electrolyte. Let me show it. It is filled with some electrolytes. Okay. It's the cell structure. Now moving onward, the reactions of uh, the dry cell. As in dry cell, zinc act like anode. Act like anode. So on the reaction, zinc undergo oxidation, while in the dry cell, cathode, the carbon or the manganese dioxide act like cathode, carbon graphite. So the reactions look like this. After balancing the reaction, and we can write the overall reactions look like this. Okay. During the reaction, zinc Zn2 plus ion and NH3 plus ions are produced. During reaction, Zn2 plus ion and NH3 plus ions are uh, produced and react to form a complex. They will react together to form a complex which looks like this. That is tetraamine zinc second. Okay, Zn NH3 4 2 plus ion. Next important point is that the voltage supply. I already discussed that the primary battery have a low voltage supply but long lasting. This primary battery, you should remember, will supply only 1.5 volt, 1.5 volt continuously. You can memorize the reactions, but it's not very much important. Only the important here is that you should have a knowledge of dry cell anode, cathode and the electrolyte used. Let me revise it so that you can memorize for a longer period. Now, in dry cell, the zinc container is going to act like anode. Zinc container is going to act like anode, while the carbon graphite rod is going to act like cathode. The space between the two is filled with manganese oxide, carbon, along with some electrolyte, the liquid form, that is ammonium chloride and zinc chloride. It's all about the dry cell. Moving to another different type of cell. Second one is the mercury cell. Mercury cell is also known as the button cell. Okay, it can be called as mercury cell or the button cell. We should focus on construction, that is anode, cathode and the electrolytes used here. In our mercury cell, as you are seeing in the slides, that mercury cell consists of anode made up of zinc amalgam. What do you know what is amalgam? Any metal mixed with mercury is known as the amalgam. So in the mercury cell, we are using zinc amalgam as an anode, zinc amalgam as an anode, while cathode is the mercury second oxide, that is the paste of mercury second oxide along with the small amount of carbon. And the electrolyte here used is paste of zinc oxide plus potassium hydroxide mixed together form the electrolyte. Anode, cathode and electrolyte is very important to remember in case of mercury cell or different type of cell. In this cell, the voltage supply is different, that is 1.75 volt, 1.35 volt, sorry, 1.35 volt, but in case of dry cell it is 1.50 volt. Now we can focus on the reactions. Anode, as zinc amalgam is using as an anode, so zinc undergo oxidation to form zinc oxide, while cathode, a mercury second oxide or the paste of mercury second oxide undergo reduction to form mercury in the liquid form, and by balancing the reaction and cancelling out the equal number of electron, we get the overall reaction. As this overall reaction, you are seeing that does not involve any ions. This overall reaction does not involve, that is zinc, mercury second oxide and zinc oxide and mercury liquid either in the reactant or product side, does not involve any ions. So there will be no change in the potential before and after the reaction or during the working of the cell. That is, a mercury cell has a specialty that it can provide a constant of 1.35 volt during its working. Okay, the cell potential cell potential of a mercury cell always remain constant as overall cell reactions of a mercury cell does not involve any ions whose concentration can be changed during the lifetime of the working of cell. Okay, this cell is suitable for low current devices, you know, hearing aids, watches, cameras and the toys. Okay, till now we have discussed about the primary batteries like dry cell as well as the mercury cell. Now it's time to discuss about the secondary cell. Secondary cells or the secondary battery means those batteries that can be recharged or can be used multiple times by charging or discharging. Okay. Lead storage battery is one of the secondary battery which are in our syllabus. Let's start with the lead storage battery. As the word itself indicate that lead storage battery. It means this battery is composed of lead as a important material or the special material. In this lead storage battery, as you can see on the screen, the structure of the lead storage battery, anode and cathode are present alternatively, that is one cathode, one anode, one cathode, one anode, and so on. Okay. Important things from the examination point of view is that you should remember that anode in lead storage battery is composed of lead rod, while cathode is composed of lead grid packed with PbO2, that is lead oxide. This anode and cathode, as I already told you, are present alternatively, that is large number of anode and cathode present alternatively. One important question asked in the previous year examination is about the electrolytic material used in the lead storage battery. In the lead storage battery, the electrolyte is H2SO4, that is aqueous solution of the sulfuric acid. You should remember that it contains 38% by mass. It contains 38% by mass of H2SO4, while the remaining 62% is the volatile water. Okay. Now it's time to discuss about the working of the lead storage battery. You already know what is anode, cathode, and the electrolyte in the lead storage battery. Anode is made up of the lead rod which undergo oxidation, because it is obvious that on anode oxidation will occur. If anode, that is you can say lead is made up of Pb. Let me change the color. Lead is made up of Pb. It will undergo oxidation to form Pb2 plus ion. Pb2 plus ion, that is lead is oxidized. Okay. As it is written on the screen, you can see that at anode lead is oxidized to Pb2 plus ion on reaction with H2SO4 electrolyte, resulting the formation of insoluble PbSO4. It means the reaction final product at anode is lead sulfate. Similarly, at the cathode, the lead oxide that is made up of that is anode. Sorry, by mistake. That is cathode lead oxide undergo reduction. Here you can see the lead oxidation number is +4. Lead oxidation number is +4, which undergo reduction to produce the Pb2 plus ion in the presence of aqueous H2SO4. Similarly, it also results in the formation of PbSO4 lead as a final material. So in terms of conclusion, we can say that either anode or cathode, after reaction the final product formed will be PbSO4. So we can say that during the reaction the concentration of H2SO4 continuously decreases. As it is written at the bottom of the screen, you can see PbSO4 is formed. Now discuss about the reaction of lead storage battery, that is the reaction occurring at the anode cathode of the lead storage battery. Lead storage battery is composed of anode where Pb is acting like an anode. Pb undergo oxidation to form PbSO4 having the oxidation number +2, which indicate that it undergo oxidation, while at cathode you can see that PbO2 having the oxidation number of +4 undergo reduction to form PbSO4 with the oxidation number of +2. It means at anode lead undergo oxidation to form PbSO4, while at cathode PbO2 undergo reduction to form PbSO4. It means both anode and cathode product will be PbSO4. As a result, the concentration of H2SO4 ions or H2SO4 electrolyte continuously decreases during the discharging of the battery, that is lead storage battery. If the lead storage battery is a secondary battery, as you already know, it undergoes charging process if it is completely discharged for the reuse purpose. So we can write the reaction of lead storage battery for the charging purpose can be like this. It is during the charging of the battery, the reaction get reversed. Very important point. If the reaction in case of discharging is forward, we can write the charging reaction in the opposite direction by making the reactant product or product reactant. You can memorize this reaction for the charging purpose as follows. Okay. Now its important point about the lead storage battery is that lead storage battery is a secondary battery. Lead storage battery is a secondary battery. It means that it can act like an electrochemical cell as well as the electrolytic cell. It means it will act like an electrochemical cell when chemical energy is converting into electrical energy, that is during the charging time, while it will act like an electrolytic cell, during the discharging time. So our lead storage battery can act like primary cell as well as the secondary cell. Okay. Now we will discuss about the second most important example of the secondary batteries, that is nickel cadmium battery or the nickel cadmium cell. This nickel cadmium battery is composed of anode, cathode and the electrolytic material. The anode is made up of cadmium while cathode is made up of nickel oxide, metal grid containing nickel oxide. Okay. The electrolyte used here, is KOH or NOH. It means a strong base. This nickel cadmium battery has a structure like you can say a roll or some things like burger. Okay. Let me show you about the structure of the nickel cadmium battery. Suppose the nickel cadmium battery anode is represented by the red color. And this cathode is being represented by the green color. Okay. Anode is cadmium while cathode is nickel oxide, and the space between anode and cathode is filled with jelly like material and get rolled, just like you roll a paratha, some things like that. Roll and moist with NOH aqueous solution, in the presence of the moist aqueous NOH solution. The overall reaction of the nickel cadmium battery can be represented as this. Okay, you can see that cadmium undergo oxidation while nickel undergoing reduction. So the working of the nickel cadmium battery, or in general all the battery, is a redox reaction. Now after the completion of the primary as well as the secondary battery along with their example, now it's turn to discuss or learn about the important type of a cell known as the fuel cell. As the word itself indicate, fuel, it means the raw material here is the fuel. The fuel like methane, H2 and methanol undergo combustion. The energy of the combustion of fuel directly converted into the electrical energy. That cell is known as the fuel cell. It means those cells that convert the combustion energy of the combustion of fuels directly into electrical energy is known as the fuel cell. There are a lot of examples of the fuel cell, but one of the important example that is in our syllabus is H2O2 fuel cell, that is hydrogen oxygen fuel cell. This fuel cell is different from other cells, that is the primary or the secondary battery, in the point of view that the raw material that is required for the working of the fuel cell is not present inside the cell. But unlike in the other primary or the secondary batteries, you saw that the raw material that is required for its working are present inside the cell. Now let me explain about the working of the fuel cell. Please focus on the diagram given here. You should focus on this region. Okay, this fuel cell has anode. Let me take another color. This fuel cell has anode and the cathode. Anode is negatively charged and the cathode is positively charged, as you can see. And the there are the two different roads. Let me show by the diagram. This is anode and this is cathode, and this anode and cathode are composed of the carbon with a small amount of powdered PT, PD and AU to catalyze the reaction. It means these rods are mainly composed of carbon with a small amount of the powdered form of platinum, palladium and AU or AG. Okay. The space between the two electrodes, are filled with the electrolytic solution, that is concentrated NaOH or the KOH solution. Concentrated NaOH or the KOH solution. Now it's time to discuss about the working of the fuel cell. Here the hydrogen gas, as you can see on the anode side, hydrogen gas is passed. As the hydrogen gas is passed toward the anode side, hydrogen gas undergo reduction. Sorry, by mistake. Undergo oxidation to form water. Due to the oxidation of hydrogen gas at anode, it will form water. Similarly, oxygen undergo reduction. To form water. So it's now obvious to you that the reaction at anode and cathode will form water, and this water is collected between the two electrodes, and the water can, if water level crosses the battery level, then it come out or can be collected somewhere, and this water can be used for various purposes. Now you can read the statement as H2 is fed to the anode compartment where it is oxidized to form H2O, while O2 is fed into the cathode compartment where it is reduced to form H2. It means hydrogen undergo oxidation to form water, while oxygen undergo reduction to form water. In both the cases, water is the final product, which is non-polluting. It is the advantage of the fuel cell that its final product is non-polluting, as well as it's providing the electrical energy. There are a lot of achievement or the advantage over the other cells. Let's discuss about them. Okay. Before starting this, you can understand about the reactions of the fuel cell. Hydrogen undergo oxidation to form water, while oxygen undergo reduction to form water. Okay. Overall reaction can be written as, but it is not very important for you. Now the highlighted portion is the advantage of the fuel cell. What is the advantage of the fuel cell over the other cell? Here the fuel cell efficiency is much more than that the thermal power plant. Thermal power plant efficiency is found to be just 40%, while the efficiency of our fuel cell is about 30% more, that is 70%. So which cell you will choose? You will choose obviously the fuel cell, because its efficiency is much more than that of a traditional thermal power plant. Additionally, one more advantage is that it is non-polluting and eco-friendly, because the only byproduct here produced is water. Fuel cells are non-polluting, eco-friendly, because only waste is product, or the byproduct you can say, is water, which is non-polluting. Also, it is a continuous source of energy. I want to draw your attention toward an important formula which is not mentioned in NCERT but asked in the various competitive examination, like is this: the efficiency of fuel cell or the other cell, how can it be calculated? The numerical related to this formula is not asked in the previous examination, but just formula is asked. So it's better to memorize this formula, as efficiency of fuel cell can be calculated as the ratio of delta G upon delta H. And as you know, the delta G from the electrochemistry and the maximum work done by the cell, delta G can be written as minus an Fe cell and delta H as such. So these are the two different from which the efficiency of the cell can be calculated. One should memorize this. Okay, moving to the achievement, moving to the okay. Slide changes by mistake. I want to draw your attention toward the achievement of the fuel cell before discussing about the corrosion. Okay, probably you have read about the achievement of the fuel cell. One of the important achievement of the fuel cell is that as its byproduct is water, so it was first used by the Apollo space program for providing water to the astronomers where the water is not present. One of the greatest and interesting achievement. Now, without wasting the time, we have to discuss about the corrosion. Corrosion is the deposition of some undesirable or unwanted substance on the surface of a metal. On the surface of a metal. Okay, we can say what is corrosion is the deposition of undesirable substance on the surface of metal. It is harmful for the person as well as the economy if undergo on the large scale. We are not going to these topics, but chemically we have to understand what actually the word corrosion means. Corrosion is a spontaneous process. Corrosion is a spontaneous process. It means it will occur by itself and irreversible. Please remember, it is a spontaneous and irreversible process. And some person understands or know that corrosion is a physical change, but remember that the corrosion is an electrochemical process, means corrosion is a chemical change. Please understand. Spontaneous, irreversible and electrochemical process, due to which the pure metal is converted into undesirable substance when react with air and water. In your earlier classes or the junior classes, you have learned about the condition of the corrosion, that is the presence of air and water. Now we can focus on this. In case of copper, green coating develops. This is known as the corrosion in case of copper. But in case of iron, you all know that reddish brown layers is formed, which is known as the rusting of iron. One should remember that rusting word is specifically used for iron. Okay. Now in case of iron, you can see in the diagram that suppose focus on this diagram. This is the iron object. This is iron object where iron in the pure form is present. This iron, due to the presence of air and water droplet undergo oxidation. This oxidized Fe2 plus ion further react with oxygen present in the surrounding to form Fe2O3. And this Fe2O3, as you can see in the diagram, react with water. Fe2O3 react with water to form a layer as shown in the reddish brown color. Let me show it again by the reddish brown, reddish something's color, which deposit as a rust. It means, let me clear you it again. There is an iron surface where pure iron is present, which undergo oxidation to form Fe2 plus ion. This Fe2 plus ion so formed react with the oxygen present in the surrounding to form Fe2O3, that is iron oxide. This iron oxide further react with water, because essential condition for the rusting is air and water to form or to deposit a layer or undesirable substance, which is known as the rust. And in the previous important formula that is asked about the formula or chemical formula of the rust. Chemical formula of the rust is hydrated ferric oxide, Fe2O3.XH2. You should remember that the formula of the rust is hydrated ferric oxide, Fe2O3.XH2O. Now, let me show you by reaction. Rusting of iron. Keep this explanation in mind so that we can understand in a better way. Anode. Iron is getting oxidized by the loss of electron, forming Fe2 plus ion, just like this, forming Fe2 plus ion. This Fe2 plus ion undergo oxidation to form Fe2O3, and cathode, oxygen react with 4H plus ion present in the surrounding to form water. and the overall reaction can be represented as such. Okay. Now ferrous ion further react or oxidized by the atom oxygen, as I already told you, oxygen atom to ferric ion Fe3 plus ion, which comes out as rust in the form of hydrated ferric oxide Fe2O3. The reaction about the rusting can be represented as, and please focus on the prevention. How can we prevent the rusting? Is that by oiling, by painting, by galvanization with zinc, or by electroplating with magnesium and zinc, and other prevention methods you already know. Okay, it's all about the third part of the electrochemistry, where we learn about primary battery, secondary battery, their types, and lastly we'll discuss about the corrosion. Now this topic is completed. Watch this video and share to all among your friends and other persons. Goodbye. Thank you so much.